Alright, welcome back, math friends. Today I want to talk a little bit about the area and volume of rectangular figures. But before we get into some explanation and some example problems, I think it's probably important that we know exactly what area and volume are. So we'll define area as the measurement of the amount of space taken up by a two-dimensional figure. And volume then will be the measurement of the amount of space taken up by a three-dimensional figure. So if you're taking these notes for the first time, please copy them down. You'll probably want to hit the pause button and join us after you've got it all jotted down. But we're going to roll on forward. Before we get into the example problems, I'm going to be talking quite a bit about multiplication and why multiplication makes sense for area and volume calculations. So I think we need to make sure that we're operating with the same understanding of multiplication. And the first way that most people learn multiplication is that it's repeated addition, which is great and true and fine. But I also like to think of it as talking about groups of the same size, and I think that's helpful for understanding how and when to use multiplication. For example, if you have 3 baskets of 4 oranges each, you have 3 times 4, 12 oranges total. And that makes sense because you have groups of the same size. So we'll be using that definition a little bit as we go into our first problem. So I want to talk about the area of a ping pong table. The area on top, how much space is on top in 2 dimensions on top of that ping pong table. And as you can see from the picture that they have the length as 9 feet and the width as 5 feet. And so the formula or the equation we can use for the area of a rectangular figure is length times width. Area is equal to length times width. And that is true, and the formula is great and really useful, but I need to make sure that we understand why this multiplication makes sense. Why are we multiplying length and width? And most people will memorize it, and that's great, but I also want to give you a way to maybe understand it so that it's not just memorized, but really understood in a deeper level where you can prove it to yourself. And to do that, we're going to use that definition we just talked about and also this little picture here. So I'm trying to show that indeed we do have a width of 5 feet. In this picture on the right, we also have a length of 9 feet. And so what we're trying to find out is the space taken up in 2 dimensions, and you might be able to do this right away, which is great, but I also want to try and see if you can understand this with me in the way that I think makes sense. We're wondering how many of these boxes, how many of these 1 foot by 1 foot boxes or units will fill up this entire space in 2 dimensions. And like I mentioned earlier, I like to think of multiplication as groups. So I see this as multiplication because I do see groups here. I see 9 groups of 5 feet. This top group of 5 feet, that's one group or one row. But then we also have a second group of 5 feet and a third. And if you can see where I'm going, we're going to have a total of 9 groups of 5. And so multiplication really makes sense. If we have 9 groups of 5, then we can say we have 9 times 5 to find out the total number of 1 foot by 1 foot boxes or square feet that will take up the area of this ping pong table. So we have a length and a width, and we can plug those in to our equation. And now we understand a little bit better maybe why we're using multiplication. But our length, we said, was 9 feet, and our width here is 5 feet. And so we'll just do a little math facts that you have memorized. We'll know 9 times 5. That will give us 45. And we talked about how the units have to be these square feet, or feet squared. But if you know something about exponents, then you can also see that feet squared makes sense, feet with an exponent of 2, or square feet, because we multiplied the 9 and the 5, but we could also say we multiplied feet times feet. And whenever you multiply anything times itself, we know that we can express that by using an exponent of 2. So the area of this ping pong table would be 45 feet squared, or 45 square feet. So there's area. Hopefully we're understanding the multiplication a little bit better. And right along with it becomes the idea of volume, which is just kind of one step above area for calculations for rectangular figures because it just has one more dimension, and that's height. So let's name some of these measurements we have. We have a length there. Let's call this a length. Let's call that 12 feet. Why not? Looks close enough. We also have a width. We can call this width 5 feet. And finally, the new measurement we have for volume is we have a height. So we'll say that this height maybe is 3 feet. So not deep enough to dive. But we have a length, a width, and a height. And I just want to talk really quickly about why it also makes sense to multiply the height. Because we can talk about finding an area as finding the length times the width. So bear with my drawing. But it makes sense to say that that's an area of 6 square units because we have a length of 3 and a width of 2. So we have 2 groups of 3. So groups make sense to multiply. But when you have a height, I also like to think of it as having levels of that group of 6. So yes, on the top floor we have one level of a group of 6. But if we have a height, it's actually going to extend, and we're going to have multiple levels of 6. So we need to say that those different levels could be considered more groups. So in this picture I'm just drawing over here, we don't just have the top group of 6, which I'm going to kind of color in really poorly, these 6 cubes, but we have a total of 1, 2, 3, 4, 5 levels of 6. So this figure is going to be made up of 30 cubes because you can think of each of those levels as a group, and that's why we're going to multiply by the height when we're using the volume equation. So the volume equation we'll use is volume is equal to length times width times height. So first we find the area, and then we multiply by how many levels or how many groups we have of that area. So let's go ahead and plug in. We said our length was 12 feet. We said our width was 5 feet. We gave our height as 3 feet. Now we can multiply these in any order we want, and that's called the commutative property of multiplication. As long as we multiply them all together, we'll get the same answer. But let's just multiply those first two and find out what is the area at the bottom of that pool. What is the area there that we get by multiplying length and width? And 12 times 5, we know this is actually volume of a rectangular prism. I need to make sure we clarify this because not all volumes are calculated length times width times height exactly. But 12 times 5 we know is 60, and areas are in feet squared because they have 2 dimensions, but we still need to multiply by this height and see how many levels we have. So our final answer for this volume of this rectangular prism is going to be 60 times 3. We can do that mentally. 6 times 3 is 18. Then we'll multiply that 10 back in for 180 feet cubed. And you can see that these are little cubes that we're dealing with when we're measuring our volume. Each of those is a cube, and it makes sense because cubes can take up space in 3 dimensions, and that's what our volume is measuring. So we could say that 180 feet cubed of water is what will be held in this pool. So hopefully these explanations of why we're using multiplication in our formulas are making sense. And hopefully these have been helpful. But I want to leave you with some practice problems to work on your own. So these are your problems, not my problems. I have my own problems that I need to deal with, as my students are well aware. But number 1 is find the area of a pool table that is 5 feet wide and 7 feet long. And number 2 is a ping pong table that is 9 feet long and 5 feet wide stands 2.5 feet off the ground. What volume of storage space is available below the table? So hopefully you can copy these down or give them a shot on your own. Maybe use a picture if that helps. But really, the formulas should suit you well. So do your best. I hope you got it down. and I will see you on the next video. Thanks.